So have a look at question 4, right? Fairly straightforward. We can just treat this as a quadratic, like x minus 1 and then y plus 2, for example. Okay? So there's two brackets, multiply them out. So just got to make sure that we use distribution law. So everything in the first has to meet up with everything in the second. Okay? And then we can just multiply these two things out. So we should get 4i times 3i, which would be 12i squared. 4i times positive 2, which is positive 8i. Negative 1 times 3i, which is negative 3i, and then negative 1 times positive 2, which is negative 2. Happy with that? Then we can do a bit of simplifying. Now have a look at this. What would I squared be equal to? It's negative 1, right? So 12 lots of negative 1 is just perfect. Then we've got 8 lots of I, take away 3 lots of I. What's that? Good, it's just because they're numbers, because I is just a number, it works in exactly the same way as the numbers that we are familiar with, the real numbers, okay? Then we've got minus 2. And then finally you can see negative 12 and a negative 2 there to make negative 14. So you get negative 14 plus 5i, okay?
5 is minus 8 plus 6i, right?
I don't know yet, let's see. Yeah, let's see. But just be careful of this, okay? Have a look at the form which we leave our complex number in. Okay, and I'll talk a little bit more about the form in just a second. Can you notice there's two parts there? There's a real part. The negative 14 is our real part. Yeah, that's the real number. Negative 14, we're familiar with that. Yeah? And then you've got the 5i, that's the new bit. Okay, you've got 5 lots of the imaginary number. That bit there is imaginary. Okay, so you've got a real part and an imaginary part. When you put them together, you get your complex part. You get your complex number. Okay, so real plus imaginary, that's how you get complex. Okay, complex just means in this case not hard. Okay, complex means 2 parts made up of multiple parts. Okay. What was question 5? 1 plus 3i? All squared. Okay. Well, okay, you can think about this as 1 plus 3i multiplied by 1 plus 3i. Okay. So if we multiply this out, you get 1 times 1, which is 1. And you get 3i plus 3i, which is 6i. And you get 3i times 3i, which is plus 3i squared, or plus 9i squared, sorry. Okay. Okay, 9i squared is the same as what?
Minus 1.
Negative. Well, I squared is negative 1, so 9 times negative 1 is going to be negative 9. 1 take away 9 is going to be negative 8. And then you've got the 6i. So again, there's your real part, there's your imaginary part. We've got a complex number going on. Okay? Okay, what about number 6? Can somebody read it out to me?
1 over 4 minus I squared.
4 minus I squared. Okay.
No, cube.
Cubed. Okay.
Sorry.
That's all right. Okay. So this one here, we can do a little things with this, I guess. We want to sort of leave it as all possible by simplifying it. Don't really want a fraction if I can help it. So what I can do is I can do rationalization. Okay. So you might have seen before, if you have something like 1 over a minus b, okay, or y, let's actually use an example. 3 minus root 2. At the moment, that thing there is irrational. You happy? Because you've got an irrational number there, okay? So the denominator is irrational. Now this is a nightmare, because if now, for example, I wanted to add on 1/3 or something like that, it's more difficult to try and find a common denominator. Not impossible, but it's more tricky. So it's just easier if I have a nice rational denominator. Okay, it's more helpful for the things which I do with fractions. So what would I multiply by to make this denominator rational? I'd multiply by 3 plus root 2, right? I literally multiply by exactly the same thing, but I just change the minus to a plus. The reason why I do that is it's now just difference of 2 squares. This thing now is hopefully going to come out rational when I multiply it together. Root 2 times root 2 makes positive 2. Okay? And you also notice because it's plus and 1 minus, the difference of 2 squares means that I get 3 plus root 2, take away 3 root 2. Okay, so 3 root 2, take away 3 root 2, the root 2's have gone. So the entire thing is rational. Now when I multiply by this thing, you're happy this is just 1, yeah, because it's same numerator, same denominator. When I multiply by this thing, the only thing that I've changed is the sign of the thing in the middle. Okay? So in which case I would call that a conjugate. So conjugate simply means I keep every other term the same, it's just I change the sign of the thing in the middle. So if it's minus, I change it to a plus. If it's a plus, I change it to a minus. Okay? So I can do a similar thing here. Now before I do that, I don't really like the fact I've got I cubed going on. I want to try and simplify that if at all possible. So do I know what I cubed is equal to?
Minus I.
Yeah, good. You see that? It's equal to negative I. So I get 4 minus, and then the I cubed becomes negative I. So what is 4 minus minus I? Plus I, right? 2 negatives, double negative? Good. Okay. So now I need to think. I want to try and get rid of that imaginary denominator. I think that's the way to go. I'm going to take inspiration from this. So I need to multiply by the conjugate. Okay? So the conjugate would be, well, I keep the 4 and the I the same, but I change the plus to a minus. Fantastic. Whatever happens, I need to do it to the numerator as well, because then I'm multiplying by 1. Sorry, Adele.
Sorry, but do we have to conjugate in this case? I mean, we can do 4 plus I over 4, we can multiply with 4 plus I over 4 plus I, then we still have something.
In this case you can, but just because this will apply more generally as well, I always advise you to multiply by the conjugate. Okay?
Okay.
Now because this is a complex number, and this is the conjugate of that complex number, we call this the complex conjugate. Okay? So if we have a number, and we usually let Z be the letter that represents our complex number. Okay? And you'll see that more and more in when we deal with more examples. Okay? So we usually let Z equal our complex number, in which case our complex conjugate will be that changed to a minus. Okay? And in fact, we give this a special name. It's not going to be Z. We can either call it Z star, that's fine, that can mean complex conjugate, or we can write Z bar. That would also mean complex conjugate. Now just think about these things on the complex plane, geometrically. So that's my real part of Z, and that's my imaginary part of Z, because Z is the number that I'm using in this case. Okay? You notice 4 plus I would be about there. Okay, so that's Z, that's 4 plus I. 4 minus I would be down there. So that would be Z star, my conjugate. Okay? So you notice, if I draw a vector in from the origin to that point there, you notice that the relationship between complex conjugates, okay, because of course these are complex conjugates of each other, the relationship between complex conjugates is a reflection in the real axis. So what I'm trying to do is build up this kind of geometric intuition of complex numbers. Because we've now got two-dimensional things to deal with. They're no longer just numbers on the number line, no longer just one-dimensional things. I'm trying to deal up with this kind of idea that numbers are actually two-dimensional. And when they're two-dimensional, some really exciting things happen geometrically. Okay? So don't just think about these as just ones plus, ones minus. Think about them. They're a reflection in the line. Y equals, a reflection in the real axis. Okay? They kind of mirror images of each other. Okay, so let's have a look at the last one. So what have we got? Number 7 is equal to, can somebody read it out for me?
2 plus I over 3 minus I.
Perfect, okay. So here we're going to take inspiration for what we did down here. I'm trying to get rid of that I on that denominator, okay? If you have powers of I on the denominator, always simplify those first, okay? Okay, so let's have a look. What are we going to multiply by here? What's the complex conjugate of 3 minus I?
2 plus I.
Good, so it's 3 plus I. And of course you need to multiply by on the numerator as well, because I'm not changing this fraction then. I'm just multiplying by 1. Same numerator, same denominator. Okay, so let's have a look. What's this equal to? 2 plus I times by 3 plus I. So you get 6 plus 5I plus I squared. Happy with that? Yeah? On the denominator, you get 9 minus I squared. You all happy with that? Okay. So let's do a bit of tidying up. I squared is equal to? Negative 1. So what's 6 take away 1?
6.
It's 5, I hope.
Oh, whoa.
Yeah, plus 5I. On denominator, again, I squared is equal to negative 1. 9 take away negative 1 is 10. So again, I'm going to split it up into real and imaginary. So I get 5 over 10 plus 5 over 10i. So 5 over 10 is just a half. So I get half plus a half I. Is that okay? So when it says the word simplify, as you've probably seen in maths, the word simplify is quite ambiguous because to some people, some things look simple, but to other things, they might not look simple. So it's quite an ambiguous term. But in general, when we're dealing with complex numbers and we're asking you to simplify, what we're asking you to do is leave it as a real part plus some imaginary part or minus some imaginary part. Okay? So don't leave it like this, leave it like this. Is that okay with everyone? Fantastic. Okay.